Okay, so in this video, we're going to do question 7 and probably question 8. Okay, so this is also going to require the unit circle. So it says find all angles in this interval which satisfy the following values. So what I know is that sine is positive in 2 quadrants. And as I look through all of these, I'm thinking I may get 2 quadrants for all of these answers. So let's go ahead and we'll do this together on the unit circle. So I'm going to pull that up because, as I said in a previous video, I can't split screen while having the video recording. So let's copy down all the answers here. So our first problem, which is A, asks me sine of theta equals radical 3 over 2. So the first thing I want to do is I'm saying that's positive. So because I know I have all students take calculus, I have 2 places where sine is positive. That's here and here. So what angle has a sine of root 3 over 2? Remember, sine is the second of the coordinate pairs. So there's a reference angle, a reference number of pi over 3, which is one of our answers. And then look in the second quadrant as well, match up the denominator, and you get 2 pi over 3. And there are your 2 answers. Did I do that correctly? Let me just see. Yes, I did. Okay, so that's good. So let's go on to the next one. Okay, so let's do our second problem. I'm going to keep both of these up for right now. So this next one says cosine of theta has to be a positive root 2 over 2. So I take care of where is positive first. All students take calculus. It's positive here and here. Then go up and match up your outside number. Cosine is going to be root 2 over 2 in pi over 4, and then let's go and match the reference number, the denominator, to the angle in the fourth quadrant, and we have 7 pi over 4, and those are the 2 angles that make my answer. Okay, so that's A and B, so let's get rid of those really fast, and let's do the next couple. Okay, so then the next question for 7C, so this is 7C, is that sine of theta has to equal 0. Okay, for that to happen, it has to be a quadrantal angle. And I know here, the second value is sine, that's 0, and here as well. And therefore, my 2 angles are 0 and pi. Those are quadrantal angles. That takes us to 7D. So I'm going to get everything else erased here. Okay, 7D. Tan of theta equals 1. Okay, so I know tan is positive, and to have it equal 1, it's not quadrantal. Don't get confused, because remember, tan is sine over cosine. So for it to equal 1, the value for sine and the value for cosine have to be the same value. Okay, and that only happens in the pi over 4 angles because they're both radical 2 over 2. Sine and cosine are each radical 2 over 2 in the pi over 4 angles. Okay, so since tan is positive, I know I'm in this quadrant and in this quadrant because that's where tan is positive because of all students take calculus. Okay, so then my angle, as I discussed, is my favorite angle, which is pi over 4, because it comes in so handy and it's so easy to work with. And it's going to be pi over 4 in the first quadrant and 5 pi over 4 in the third quadrant, and that takes care of 7D. So let me erase, and I'll write down 7E. So 7E is cosecant of some angle is -2. Okay, I always find out the quadrants first. All students take calculus. Okay, Cosecant goes with sine. So where is sine negative? Well, sine is positive in the first and second, so therefore it's negative in the third and fourth. Okay, so now I have that taken care of. If cosecant is -2, then the sine of that angle has to be the reciprocal, which is -1/2. Go up to your first quadrant and find the reference number that has a coordinate pair for sine of +1/2. And that's right here at pi/6. So I can't use pi/6 for an answer, but I'm going to match up the denominators and grab the two angles that will have negative sine and therefore negative cosecant values. And they are 11 pi/6 and 7 pi/6. And that's the answer to E. Okay, then we have an F. So let me just erase this and we'll talk about problem F. So 7F is the cotan of theta equals radical 3. Okay, so cotan and tan go hand in hand because they are reciprocal partners. So all students take calculus tells me that I will have an answer in quadrant 1 and in quadrant 3. Okay, so cotan is cosine over sine. In order for cotan to be radical 3, then the cosine must be radical 3/2, and the sine must be 1/2, because then the 2's cancel, and I get a radical 3 for my answer for cotan. Okay, so where does that happen? Where is cosine √3/2? That's going to be at pi/6. Okay, so pi/6 is going to be an answer because cotan is positive there. And the other angle, I'm going to match up my denominator of the pi/6 reference number, or t-bar, whatever you want to call it. And that other angle will be 7 pi/6. And we have completed the problems for number 7. So we're going to go on, and we're going to talk about the problems for number 8. And I'm going to do it the same way I just did these because I need to have the unit circle. So I'm going to write the problem down here, and then we'll work it out. Okay, so if I need 8a, so 8a says that t, so the angle, is 4 pi/3. And they want to know the quadrant, so I need to know the quadrant. And they also need to know the associated terminal point on the unit circle. So that's the coordinate pair. So first off, I'm going to find the quadrant. So 4 pi/3 is right here. So my quadrant is quadrant 3. Now what I know in quadrant 3, only tan is positive, but sine and cosine are both negative. So if the angle is 4 pi/3, go up to the reference number and grab those coordinate pairs, but make them both negative. And then you are good to go. So that is our answer for 8a. These are both negative, and I know I'm in quadrant number 3. Okay, so let's do 8b. 8b, they tell us the angle, and why don't I just change color so that I would erase things yet. So they tell us that 8b, the angle is -2 pi/3. Okay, so you can do this two ways. I see that +2 pi/3 is right here. So if I travel that distance in a positive fashion, I'll get to the angle. What if I travel that distance in a negative fashion? I will get to 4 pi/3, and I'll be in quadrant 3 for that angle. Let's say that I'm not comfortable traveling in a negative direction. Take your angle and use your coterminal knowledge add a full circle, which I'm going to add as 6 pi over 3, and that will get me 4 pi over 3, which is the exact same angle I got to by thinking in a negative direction. So that quadrant is quadrant 3. It's 4 pi over 3. In quadrant 3, everything's negative. So the coordinate pair, looking up and modeling with pi over 3 in the first quadrant, that's your reference number. It's going to be negative 1/2 and negative root 3 over 2 for our coordinate pairs. So actually, question 8A and 8B have the same answer for different reasoning. Okay, let's do 8C. So I'm going to write this down here. Okay, so 8C looks like this. So they are telling me that the angle is, and this is 8C, t equals 7 pi over 4. So first thing we're going to do is look at the unit circle and find that angle. It is right here. Therefore, it is in quadrant 4. In quadrant 4, the y values are negative. So I'm going to go up to quadrant 1, find the pi over 4 angle, look for its coordinate pairs, and negate the y value. And that's the correct answer for coordinate pairs for 8C. Okay, let's look at 8D. I'm going to get out of here. Okay, so 8D is a little tricky, so don't be fooled. Okay, so this is 8D. T is 14 pi over 6. That's not really helpful to me because it's not reduced. So couldn't I also say that T is 7 pi over 3? Okay, so if P is 7 pi over 3, where is it on the unit circle? Well, it's not on the unit circle in its current form because this is where 5 pi over 3 is. So 7 pi over 3, if I keep going around, is going to be right here. But let's say I'm not comfortable going around. Take your 7 pi over 3, that's too big. Subtract away a circle. Now, this is where the problem is, right? Because 7 pi over 3, I can't subtract away a circle in thirds. Well, can I? Yeah, I can. Never mind. 6 pi over 3. Of course I can. Okay, so 7 pi over 3 minus a full circle, 6 pi over 3, gives me pi over 3, which is exactly where I said we would be. So view your angle as being pi over 3. Give me the coordinate pairs. They're right there. They're both positive because I am in the first quadrant, so I would expect nothing less. And 1/2 comma root 3 over 2 is my answer. Now, you have to be careful with this problem because your reference angle is not pi over 6. It is pi over 3. So make sure you look and see if you can reduce a fraction, reduce it first before you get to work. Okay, let's go on to E. So we're up to 8E. So I'm going to erase that real fast. Okay, and let me write down 8E right here. So 8E says T is negative 7 pi over 3. Okay, so that's too big and too negative. So why don't we add a circle? If we add a circle, it would be 6 pi over 3. That's going to give us negative pi over 3, which I know is going to be right here. But let's say we're not comfortable with that. Take your negative pi over 3 and add another full circle. That gives you 5 pi over 3, which is exactly where I said we were. So in order to get to what quadrant am I in? I am in quadrant 4, and now let's get our coordinate pairs. Go to quadrant 1, match up the pi over 3, or the 3 denominator with pi over 3 as your reference number or t-bar. Your coordinates in quadrant 1 are 1/2 and root 3 over 2. But that's not your answer because in quadrant 4, the y value is negative. So make your y value negative, and then you have solved 8e. So let's go on to 8f. We'll do that right here. Okay, so look at 8f. And 8f says t is 17 pi over 6. I can't reduce it, but 11 pi over 6 is the highest I go in my unit circle. So I'm just going to go directly and start subtracting away circles. So 12 pi over 6 is a full circle. That gives me 5 pi over 6, which is on my unit circle. Where is that? It's right here. That is quadrant 2. In quadrant 2, my x is negative. Match up your 5 pi over 6 denominator to pi over 6. Pi over 6 would have coordinates of root 3 over 2 and 1/2 in the first quadrant. And in the second quadrant, that differs by having the x be negative, and you are all set. And that ends this video.